Um, Hi. So every day, we hear this concept like time is actually a fourth dimension of universe. So what is this fourth dimension and how can we visualize it? So that's going to be the topic of this video. So the fourth dimension is, mathematically speaking, let's start with a simple one dimension. One dimension is like a single line, right? In which you can only move in one direction, ahead or backwards or forward or backwards. Similarly, if you talk about two dimensions, let's say I draw another line which is perpendicular to it, and now we are in two dimensions. So any my let's say if I'm here, if I'm a small person, this dot can move here, dot can move here. It can move in two directions, right? So we are in two-dimensional world right now. But if we add another third dimension like that, sorry, it's I cannot draw the perspective here, but just let's say here it's x, y, and z. This is the origin of our coordinate system. So this is a three-dimensional world which we live in. We have a length, we have a width, and we have height. So, and that's the most common experience of our daily life. The problem comes that since our brains have evolved to adapt to this 3D world around us, they have never experienced anything beyond it. For example, fourth dimension, we have never had any experience, direct visual experience of fourth dimension. So we cannot see it, so we cannot imagine it even. Similarly, at a quantum mechanical level, quantum mechanics looks to us weird because our brains have never seen anything like that. So that's why it looks weird to us. There is nothing weird in it. That's how the universe works. But our brains are limited by our experience and our limited perception. So let's try to see that how we can move past this limited perception and see into more deeper into the universe and into the mathematics. So let's start. So one of the tricks which I most commonly use, and I guess all the other people use as well who work in physics or maths, is that let's say if I have a three-dimensional cube like this, okay, and I want to visualize its motion through time. Now, Einstein's special theory of relativity, no, sorry, I guess it's general theory of relativity, treats time as a fourth independent dimension in which objects can travel. So we, since are three-dimensional objects, and we only see ourselves in three dimension at any instant. So basically, what you just like a movie. At any moment we only see two-dimensional pictures on our screen, and just like that, the world around us, the universe around us, is actually a three-dimensional cross-section, three-dimensional picture of a continuously long movie. So what we can do is that fourth dimension is the way universe moves along the direction, in the direction of time. It evolves in the direction of time. So that now we cannot say it's straight or it's anything. It can be anything that the travel, but let's go ahead and try how to visualize it. Now let's say this is like a box here, right at this point, right, this box here. Now there is a dot in here. Now after one instant, like let's say 1 second, so we have this box again here. Obviously it doesn't look the same, but just for the, and this box dot has moved into the middle of it, right? So these two pictures actually tell us the snapshots of this cube moving in fourth dimension, moving in time. right? This ball is moving downwards, and if I draw another snapshot, so it can be at the bottom surface, and here it is at the bottom surface. So this is another snapshot, a three-dimensional snapshot of this, obviously drawn on a 2D paper, but you get the point. So how do I continuously realize? So you can look at the pattern. If we just fill in these three-dimensional sequences like 1 2 3 4 5 6 7, say ahead and head, so we can say that this line which connects all these boxes at different instances of time is actually a line in fourth dimension. Obviously it's not a line, but it's a conceptual line in fourth dimension that connects the past with the future. Okay, so how do we represent it on paper? We have just seen one method, but it's a very cumbersome method. So what usually we do, the physicists and people do, is that since all the dimensions of space, like the three-dimensional length, the length, width, and height, are similar to each other, well, so what they do is that they kind of kill this dimension, like, and instead replace it with the dimension of time. So what they basically do is that they make the universe a two-dimensional, like, so what you do is that you squeeze this box together into each other, so that it becomes a very, very thin slab, a square slab like this, and it has it like this, right? So they treat the universe as this very thin two-dimensional piece, two-dimensional object, and then this is this x, and this is z, and this third dimension becomes time. So they continue, for example, if I rotate my coordinate system like this here, so let's say here this is z and this is time, right? So here's my box, which let's say here as time equals to 0, the dot is here. So at the next instant the dot has moved a little bit down, right? So it has been down, and similarly for the next instant I can see it's a little down, and for the next instant I can see it's going further down, and so on, whatever you want to make it. So you see that this trajectory here, right, these slices of objects, just like here, they actually represent snapshots in time. So this trajectory is the space-time trajectory, that like how the objects moves in time, basically. So it can be anything, a curvature or a ball. So so that's how usually physicists try to picture the fourth dimension. So many 2D slices stacked upon each other in the dimension of time. The universe is treated as 2D slices stacked upon each other at time. So you might have heard the concept of light cone, right? It's exactly like that. How to make a light cone? So what you do is basically is that, just imagine, so any point of light, like just you flash an LED light, a small LED light, and it emits radiation like in many directions, like at the speed of light. So at any instant, the light that has left this the sphere, this LED forms a sphere around this, right? So let's say after some seconds the sphere grows bigger and bigger at the speed of light. So that's basically it. But how can you like represent all different spheres of light, how they grow bigger? So if you look at it, let's say at small instant the sphere was this one, then this one, then this one, then this one, then this one, and with time it grows in size, right? Yeah, so it's a z, or it's a radial dimension, so it's kind of grows in size. So if you can see, it's a light cone, it goes it like that. Now obviously these are spheres stacked behind each other. It's not like that. Sort of it's like that, but we cannot actually put spheres on to each other because it makes the visualization very complicated. So what they do instead, and also it becomes discrete. So what we want to do is that we reduce the one dimension. Instead, what we do is that instead of the sphere, which is like this and this, we make it a circle. So our light actually source from here, it comes out from here in form of rings at different times. And then what we do is that here I will redraw the axis here. This is x, y, this is my 2D spatial dimension, this is the dimension of time. So it starts at here, light, and then after some moments it becomes like this. The circle of light grows, and after some moments the circle of light grows, and after some moments the circle of light grows. And if you try to connect the boundaries of all these circles here like this, what you will get is a light cone. So a light cone is actually a depiction of fourth dimension in 3 dimensions. So this basically tries to eliminate one spatial dimension and replaces it with the time dimension. So that's one of the ways you can imagine how time or the fourth dimension can be constructed or imagined.